Hello everybody, this is a presentation for my Year 12 Mathematics students. What we're going to be focusing on today is the exercises in 2B from the chapter, and these are mainly about literal equations with some applications up into some simultaneous equations. So we'll start off with a relatively easy one. Here we have an equation, ax plus b is equal to dx, and what I want to do is to solve for x. So see how the x's are on two sides, that side and that side. I think I might get all the x's onto one side. So what I'll do is I'll take away dx from both sides. So if I take away dx from both sides, dx cancels out on that side, and now I have all the x's on this side. Now the other thing I might do, and I just thought of this now, is I'll take away b from both sides. So what I'll do is those b's will cancel out, and I'll end up with ax minus dx is equal to negative b, because the b on this left hand side will cancel out. Alrighty, I still have the x's in two spots, but I can factorize that. So I'll go x is that. So now I've factorized that expression that was in the previous line, and the x's are all in one spot on one side, which is the objective of any literal equation. Now I'll divide on both sides by a minus d, and that'll cancel out and just leave x on its own, so that'll be minus b is equal to a minus d. Now I guess the other thing I could do if I wanted to is to take out a negative there from this bottom line. So negative times d will give me back negative d, and negative times a will give me back, a negative times negative a will give me back my positive a. And then I could cancel out those negatives, so x could be equal to b over dA. Alright, let's move on to the next one. Okay, so here's the next one, and the next one is much more complicated, unfortunately. What we've got here is two fractions, and we've got to solve for x. Now, what we're going to have to do is to get a common denominator. So what I'll do with this first one is multiply top and bottom by x plus 2a and x plus 2a. And for this one, I'll multiply by x times a and x plus a on the top and bottom. So if I do that, I'll get x plus 2a up there, and on the bottom I'll get x plus 2a and x plus a, and on this one I'll get x plus a and x plus a on x plus 2a. Now, I can add these two together because I've got a common denominator, and when I do that I'll find that I have x and x, which is 2x, and 2a plus another a is 3a, and that'll all be over our common denominator, which will be x plus a and x plus 2a is equal to 1. So now instead of two fractions equaling to 1, I've got one fraction equaling to 1, which is a significant step forward. Alrighty, I still have this fraction here, but what I can do is take this bottom part here up to the top over here. So I'll do that, and that would be 2x plus 3a is equal to x plus a, x plus 2a. Now I'll expand these brackets out, so that'll be x squared. Now when I expand it out, I'll get 3ax and 2ax squared. Now what I'll do is I'll take everything onto one side, so I end up with x squared. Now that'll be 3ax minus 2x and 2a squared, take away 3a. And now what I have is a quadratic equation, and I'll factorize out the x here. And so I have a quadratic equation. Now how can I solve this quadratic equation? Use the quadratic formula. So if I said x is equal to minus b plus or minus b squared minus 4ac over 2a. And then what I'd have to do is substitute in, well, a here would be equal to 1, b here would be equal to 3a minus 2, and c here would be equal to 2a squared minus 3. Now if I substituted all those things in, I'd get an expression for x, all in terms of a, and I would have solved it. Now it's a bit tricky to do that on this screen this size, but have a go at it yourself and see if you run into any problems, and let me know, and I'll help you in class if you do. Okay, for this third one here, we've got a pair of simultaneous equations, but we don't have nice numerical values that will easily cancel down. We have algebraic, I guess, coefficients here for x and y. So what we want to do is to try to figure out if we can cancel one of these suckers down. Now the way to do that might be to say, well, okay, let's try and eliminate, say, y. So eliminate y, so my expression is all in terms of x. Okay, well, if I multiply the top here by a and the bottom here by b, I'll end up with a squared x plus a y times by a r, and b squared x minus b a y equals bt. Now these two expressions here are algebraically similar because a times b times y is the same thing as b times a times y. Now if I simply add these together, these two will cancel out. So I'll end up with a squared x plus b squared x, and these two cancel out to be 0, is equal to ar plus bt. Now I can factorise out the x here so it's in one spot, so it'll be x a squared plus b squared is equal to a r times. Now I can divide x, divide by a squared plus b squared on both sides. So I end up with x equaling ar plus bt over a squared plus b squared. Now if I want to work out what y is, all I need to do is to substitute this x value back into either this one or this one, and I can figure out x and y in terms of a and b and r and t. So you got to have a go at doing that for yourself. Okay. The main thing is with this expression though, find how you can eliminate one of the variables, either x or y. Now you can do that by sort of matching the number of x's or y's in each expression, and then they'll cancel out when you add them or subtract them. Okay, now this last one says to write s in terms of a only when we have these two equations here. Okay, so let's see. We want to get s on its own. So given the fact that we have an a in this equation and an h in this equation, I wonder if what we could do is to get rid of the h by substituting in something else. So what about if we took this expression here and we said ah minus h is equal to a. And then I could factorise the h and say, well, that's a minus 1 by factorising out the h, and then I could say, well, h will be equal to a over a minus 1. And then what I could do is see how there's an h there and an h there. Everywhere that h is, I could write that. After all, they're the same thing. So I could say as is equal to s plus, now in place of h I could put in a minus 1. Now all I need to do then is to figure out what s is only in terms of a. Well, I've got an expression here with s's in and a's in, so let's start to rearrange it. Let me take this onto the other side, so I'll minus s from both sides. Now that'll leave me with as minus s is equal to a over a minus 1. S, take away x, cancels down. Alrighty, I'll factorise out the s there. And then I'll divide by a minus 1 on both sides. So if I divide by a minus 1 on both sides, the a minus 1 cancels out, and I'd have another lot of a minus 1 there on the bottom. So now I've got s in terms of a only. Well, I hope that helps, and if it doesn't, I'll see you in class where we can try to clarify these. Alrighty, see you then, Year 12.